Now, to understand matrix equations, you really need to understand matrix operations. So look back at the previous section if you need to. Matrix addition, matrix multiplication. However, let's see a couple of situations where matrix equations arise. The first one I'll show you is somewhat familiar because we did this earlier in the chapter. Here we have a 2 by 2 matrix. And here we have a 2 by 1 matrix, and we're going to multiply those together. Now the process requires that the two inside numbers match, which they do, and the answer is going to come out being a 2 by 1 matrix. Now the definition for matrix multiplication says that we need to multiply the first number by the first number, and the second number by the second number, and then add. Here's what that would look like. And likewise, we need to multiply in the second row, first times first, second times second, and add. So there would be our 2 by 1 answer matrix. Now we're going to give these a name. We'll call the first matrix A, second matrix X. That means that the product is, well, A times X. So here's what we're going to do. We're going to take another matrix, which is a 2 by 1 matrix, and we're going to set these equal to each other. Now the only way that matrices can be equal to each other is for the first components to be equal and the second components to be equal. Now if you look at the bottom, that should look familiar. Back earlier in chapter 4 we did systems of linear equations, and this is what they look like. So the matrix stuff that I was showing you is nothing more than this system of equations. Now we're going to take the matrix equation AX equals B and see how do we solve the matrix equation AX equals B. Well, it would be nice if we could divide both sides by A, only there's no such thing as dividing in matrices. We can, however, multiply both sides by the inverse of A. Now notice we're doing it on the left side of each side. So we put the A inverse on the left on both the left side and right side of the equation. Now on the left side, the A inverse times the A comes out to be the identity matrix, which gives us just the X. And the right side just comes out to be A inverse times B. And so that is the solution to the matrix equation. Now let me show you how we could use that to solve this system of equations. We could take the left-hand side and write it as a matrix. Notice that's a 3 by 3 matrix. We could take the right-hand side and write it as a matrix. Notice it's a 3 by 1 matrix. And we could simply do what we just came up with. A inverse times B. So if I take out my calculator and do A inverse times B, after having typed those into my calculator, this is what I would come out with. Now the answer matrix, 8, -4, -9, means that the x1 is 8, x2 -4, and x3 -9. Well, that's fine, only we have better ways of solving systems of equations than to do it with the inverse matrix method. However, let me show you this one, which you'll see where this comes from a little later in a different section. However, this is the matrix version of that. We're going to take the left side and write it as a matrix. We're going to take the constants at the right and write them as a matrix. And we're going to take the middle and recognize that's a lot like the matrix stuff that we were just looking at. We can write that as A times X, where the A is the coefficients. So we can write this system of equations, if we call these X, A, and D, as X equals ax plus d. Now, what this section is about is basically not how we come up with that, but how do we solve that now that we have it? Well, again, in matrix form, we can't go dividing. We can, however, subtract the ax from both sides. On the left, we can factor. Only the 1 in front of the x needs to be an identity matrix. So we'll just write the x as I times x so that we have an identity matrix times x, which is just x. Now, factoring out the x, remember that needs to be on the right-hand side. So factoring the x out, we get I minus a times x equals d. And again, we don't have a division, so we'll have to multiply by the inverse of whatever is in front of the x. So putting it on the left hand of both sides, right and left side of the equation, on the left, the I minus a inverse times I minus a just disappears. And we end up with I minus a inverse times d. Now, I'll show you later why that's important, but again, it's how we solved the equation right now that we're taking a look at. Just get comfortable with the idea of matrix equations and how we go about solving those. So, let me show you, back to what we had originally, how we can finish solving this problem, whatever the problem happens to be, using the matrix equation that we just came up with. So our answer matrix, X, we can get simply by combining these other matrices together. The I matrix in this problem would be the 2 by 2 matrix that would have 1s in the main diagonal and 0s everywhere else. We'll type that into our calculator as matrix I. The A matrix is what we have labeled as A up above. We'll type that into our calculator. The D matrix, that's the 12 and the 9. We'll type that into our calculator. And then we'll simply type the formula that we just came up with. I minus A in parentheses inverse times D. And as you can see, these are the answers that we came up with. Now, what the heck does that mean? We will tackle in a different session.